Ladies and gentlemen, are you ready?
What's up, guys? My name is Eric Guillen. We are here at White Point Beach in San Pedro, California, and today we're going to talk about the geological features around in this area. Let's go! Oh! Ow!
Hi guys, my name is Ashley and I'll be talking about how White Point is one of the larger parter areas of Palos Verdes. It became more open and more accessible to the public back in the 1960s, making this one of the larger coastal development and park developments of California around that time, as well as it's one of the bigger and larger tourist and where you can see many locals coming to this beautiful beach, as we see behind me over here. Very beautiful, very beautiful. Big waves, but it's a very beautiful beach and we see many tourists coming here.
Hi, so today, my name is Jose, and today we're going to be talking about marine terraces, which I'm not sure if you can see. It's actually where the houses are over there. And how marine terraces are formed is that they are wave-cut platforms. And what a wave-cut platform is that as tectonic plates move, it slowly moves up land. But the way the marine terraces are formed is that as the surface moves up, it's also getting hit by waves. And as the waves go, this causes wave erosion, which are the two factors needed. And as normal erosion occurs, it slowly takes away pieces of the rock and chips away at it. And that's what the waves do here. So as you can see, the waves down here are hitting the land here, but millions of years ago, that was happening up here. Because up here, as you can see, there's grooves in the land which were caused by wave erosion. And as wave erosion happens, it chips away the rocks and creates these marine terraces, which can be either flat or have a gentle slope to them. But because of this, it is not a very steady surface to have a house on, which typically is not very ideal, but they have houses here. Honestly, I wouldn't do that just because it's a geological hazard and how unsteady it is. But those are marine terraces.
Alright guys, so my name is Abraham and I'm going to be explaining a unique coastal cliff that doesn't happen very often. So if you get granite, which is going to be one of the hardest materials found on coastal areas, mostly in cliffs, you mix it with a little bit of slate/clay, often soft with a little bit of white and orange distinguish, usually could be broken by the sleight of hand, with a little bit of limestone, most common in coastal areas. Also, if you put them together and crush them with a lot of force, you can create something called a recumbent fold. However, let me enlarge it and show you guys. Alright, so let's get a better look at this. So, formed 20 to 15 million years ago, the collision between the Pacific plate and then the North American plate caused a collision, or also known as the Palos Verdes fault line. Because of the fault line, it created mass tension within this cliff, which is now known as the Lazy Boy fold in the city of Palos Verdes. So what we can see here is the anticline ended up causing a horizontal downward fold within the mountain material, or all the material actually that can be found here are sandstone, siltstone, clay, granite, and other various materials. It ended up causing them to fold at a downward horizontal angle. Because of this, we can no longer follow the law of superposition, just because there is no possible way to properly calculate or date these rocks anymore. Due to them being at a weird angle, sideways, left, right, up, down, we can no longer verify if the stones on the bottom are the newest than the stones on the top, since many are moved at an angle or downwards. What we can see is that it shows a great C shape of a fold. Right next to that is another crooked S shape, but what we can tell is that in about 15 million years, or 10 million years, we will get two smaller C-type folds there as well. This is a phenomenal effect that happens in most coastal areas that have two tectonic plates under and a heavy fault line. We can also see the colorization that these rocks produce, from more of a grayish white bottom to a more light tan color on top. The downfall of this situation is that this cliff is not suitable for construction or is also prone for landslides. because of it being more horizontal, it is no longer structural supportive, meaning that since it's not horizontal, it can no longer compress downwards. It will one day crumble down and fall apart if we are trying to do any type of commercial slash home building on top of it.
Hi guys, my name is Samantha Correa and I'll be talking about the riprap here at White Point. An intriguing detail here is how these rocks weren't originally from here. They were transported from granite-rich regions such as Riverside County and the San Gabriel Mountains. Each one represents a unique type of granite such as diorite and granodiorite. You'll also find gneiss here, which is a metamorphic rock. Interestingly, all these rocks come from igneous rocks, which are formed from magma, and when this magma cools slowly underground, it creates plutonic rocks with larger, more visible crystals. And these rocks are also erosion resistant, which means it's harder for them to break down. Granite and igneous rock is especially well known for being very strong and having coarse-grained texture. Rather than being a single mineral, granite is made up of several minerals. When you take a closer look, you can often spot 2 to 4 distinct colors. And this rock next to me also happens to be an example of granite. Come closer, the rock doesn't bite. And you could tell the differences when you look closely into the rock. The variety is due to the coarse, transparent, or gray quartz grains that are mixed with other minerals, creating its vibrant appearance. In sunlight, granite can even gleam. One of the key minerals in granite is mica, which forms shiny, flaky sheets. These mica particles give granite its characteristic shimmer, adding to its visual appeal.
What's up, guys? So today I'm going to talk about the basalt rocks and the conglomerate rock here that I'm standing on. To begin with, the basalt rock is an igneous rock, is an extrusive igneous rock, which means that when lava meets the ocean, it cools rapidly. So this is what happened here. And the lava that is sunk into the ocean floor is called submarine basalt. And as you can see right here, because it is on top of the water, it is just called regular basalt. And basalt is, since I said basalt is an extrusive igneous rock, it has fine-grained minerals. So it is very hard to see the minerals inside the basalt rock. And as you can see here, I am standing on a sedimentary rock called a conglomerate rock. A conglomerate rock has multiple rocks and minerals in it and fragments. And this is a little different than a breccia sedimentary rock, because these rocks are rounded and not angular, and do not have angular rocks like the breccia rock. And as you can see today, it is a high tide, and there's certain times where the tide is really high, and at this point the tide is getting higher since we got here 2 hours ago. So I think it would be safer for us to finish this video.
Alright guys, well that's a wrap for today's video. We hope that you guys were able to grasp and understand why White Point is such a big, important beach for Palos Verdes. We hope that you guys were able to understand why the main terrace, sedimentary rocks, and the igneous rocks are so important to this beach, and why it's literally made up of all the rocks, and why you guys should just come and visit, because who wouldn't want to visit? It's a beautiful beach. I would want to visit. I said we should take a dive. I'm just saying. But bye guys.